series of concentric circles, all sharing the origin as their center. So this circle is the one that has a radius of 1. The second circle, oh, is this? Yeah, and it's labeled 1, 2, 3, 4. This is the circle with a radius of 3 and then a radius of 4. And then obviously all your angles are labeled there. So 2, 135, and this is in degrees, so this needs to first be transferred back to radians. So what's the reference angle for 135? 45, which is a pi over 4, and in which quadrant? 2. So that's going to be the 3 pi over 4 is going to be your angle, and then you want to go out to a radius of 2, and that's the location of that point. So with XY coordinates, I would assume you all use the X coordinate first and the Y coordinate second, just because that's the order that it comes in. This one, and you don't have to do it this way, but I typically find my theta first and then go to my radius. So it's not in the exact order, but that's the location of that point. The second example, so this is an angle of 3 pi over 2, which is here, right? And a radius of negative 3. So you can see it goes positive 1, 2, 3, negative 3. So here's the thing. This gets a little bit, I don't know if this is tricky. It might might make sense. Radius 1, radius 2, radius 3. If we're on this ray, but we have a negative radius, then we're actually going to go backwards 1, 2, 3 to here. So our angle would open us up to this terminal ray. And if you had a positive R value, you would stay on this terminal ray. But because our radius is negative, we actually flip backwards to its opposite ray. And so what could you, I don't know, does anyone realize anything about this point? What's that? Yes. It's not always going to be that. Well, I guess you wouldn't know. But there are multiple ways of representing any given point, is the point I'm trying to make. So even though we just plotted 3 pi over 2, or negative 3, 3 pi over 2, can anyone think of another set of coordinates that would also plot at this exact same location? Say it again. 3 pi over 2, exactly. So that's just different, because that's definitely not the way of things in the rectangular coordinate system. But in the polar coordinate system, the same point can be represented by different coordinates. Okay? Try to plot this one on your own. Yeah. What quadrant did you plot it in? The second. So, that's correct. It should be in the second quadrant. So negative pi over 4 opens you up in this direction. This is, obviously it's labeled 7 pi over 4, but it's the same as negative pi over 4. And then a negative 1 radius brings you backwards. Now, it may be hard to see where the extension of this particular ray is, but that's where, Lily, what you had said earlier is a good thing to notice. So if you're going to the opposite ray of 7 pi over 4, that's going to be the 3 pi over 4 one in the second quadrant. So on that ray, be at negative 1. Good. And the last one, atom. Tell me what quadrant it's going to be in. Pi over 3. That's a 2. That's easy, right? So, working more with that last example, there are really, because of coterminal angles, there are an infinite number of ways to represent that exact location. This in the bottom, and I'm sorry, it obviously folded when I went to put it through the copier, so part of that is cut off, but it's going to ask us to write different representations. There's 3 parts, A, B, and C. Write different representations of this same point such that R is positive, and it's currently positive anyway. So we want to keep it positive 2, but that the theta is between 2 pi and 4 pi. Raise your hand when you think you know what that would have to be. What would that coordinate pair look like? I see 3 of you. Josh, Liam, and Steven. Anybody else coming out of the woodwork? A way to represent that exact same point, still with a positive R, but with a theta between 2 pi and 4 pi. Liam, what do you think? Correct. 2, 7 pi over 3. So to get between 2 pi and 4 pi, you have to go around the circle with your terminal ray at least one time to get above 2 pi, and then you'll hit pi over 3. So one full circle would be 6 pi over 3, and so then that would be 7 pi over 3. So that your theta is between 2 pi and 4 pi, but we're still with a positive R. Okay, try B. Try to write a representation of that point with a negative R value and a theta between 0 and 2 pi. Raise your hand when you think you know, just so I have an idea. Taylor jumped on board. Don't give it to us. We got to let everybody else think about. Kyle jumped on board. Jack is on board. Jalen, this is good. Haley, does that mean you're confused? Okay. Do you know the value that R is going to have to be if it's got to be negative? Negative 2. So which quadrant would our theta have to be in order for us to then, when we go to plot a negative R, would put us back in the first quadrant? The third, correct. So what is the theta in the third quadrant that would have an opposite ray coinciding with pi over 3? You got it. So negative 2, 4 pi over 3. Does anybody have any questions on that? Okay, try the last one with R being positive, but the theta being between negative 2 pi and 0. How about Nathan Zorn? So if you open to negative 5 pi over 3, here's negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3, and 2. Perfect. Good? All right. Oh man, I haven't looked at this since last year. I gotta remember these formulas. I think I got it. I think. I'm going to audit myself and I'll check the book just to be sure. But so we're going to, you switch back and forth between polar coordinates and rectangular coordinates. And what you'll find, it's kind of neat that it makes sense. The rectangular coordinate puts it in that same quadrant that the polar coordinate told you that it was in. And you'll see how the rectangular version of a location and the polar version of a location really put you at the exact same spot. So the formulas you're going to have to remember are based on your right triangle basics. So if this point is x comma y, that's the rectangular system. So here's your rectangular point. Your polar point is r comma theta. Now, where does your r come from? It's wrapped up in the Pythagorean theorem, right? X squared plus y squared equals r squared. So that's one formula that's going to be used to help you transition back and forth between rectangular and polar. Your theta, and we'll kind of let this, before I just tell it to you, I'll show you where it comes from. If you were trying to incorporate theta into an equation, what equation could you write that would give you theta? What equation could you write that would incorporate theta? Thinking SOHCAHTOA. Let's just start with the sign. If you were to write sine of theta equals, what would it equal? Yep, opposite over hypotenuse, y over r. So if you solve this for y, what does y equal? I'll put the r out in front, but yes, r times sine theta. Now, I would just memorize that. You're not going to probably want to draw the diagram every time. But the y coordinate in the rectangular system is always going to equal the radius times the sine of your theta. And if you wrote a cosine equation, cosine would be adjacent over hypotenuse. So what does x equal? Right? R times cosine theta. And what would tangent of theta equal? Y over x. These have always been true. And we've been using these all along here. So when we talked in the trig chapter about x being the cosine of theta and y being the sine of theta, remember that? Okay. That was only true in the unit circle. And the reason it was only in the unit circle is because your r in the unit circle is technically what? 1. So we kind of just never, well, I don't know, did we talk about that? Did you last year in Algebra 2? So I talk a little bit about that with my Algebra 2 kids just so that that shortcut isn't, it truly is not limited to just the unit circle. Plain cosine sine is limited to the unit circle, but if you have a radius larger than that, you just throw the radius out in front and that gives you your x coordinate and your y coordinate. So those won't be too hard to memorize just because your x coordinate has always been the cosine of theta. Now, because we're not limited to the unit circle only, it'll just be r times the cosine of theta, and y will just be r times the sine of theta. Tangent of theta has always been y over x. Okay, that's always been true. And that's the sine, r sine over r cosine. sine over cosine, so that all works. And then just x squared plus y squared equals r squared. And so those will be the formulas that you'll continuously use to go back and forth. So if we take a polar coordinate 2, 3 pi over 2, r equals 2, and theta equals 3 pi over 2. So if you want to get your x and y coordinate in the rectangular system, it's pretty straightforward because your x coordinate is just your r value, which is 2, times your cosine of 3 pi over 2, cosine of your theta. So that's 2 times, what is the cosine of 3 pi over 2? 0. So that's 0. And your y coordinate is your r value again, 2 times the sine of 3 pi over 2. And the sine of 3 pi over 2 is -1. And so the rectangular coordinates of this exact same location are 0, -2. Now if I do a quick sketch in the polar coordinate system, think about opening up to a theta of 3 pi over 2, which would be this terminal ray, and a radius of 2. Puts you right there. We can all agree that that is, in fact, the point 0, -2. Okay? All right, so for B, your x-coordinate is r times the cosine of pi over 3. What is the cosine of pi over 3? 1/2. And your y-coordinate is r times the sine of pi over 3. What's the sine of pi over 3? Radical 3 over 2, so that's going to be a -4 root 3. So your rectangular coordinates are here. Now, because there's a radical 3 in there, it's not going to be as obvious that they're the exact same point, but just let's think about, do the quadrants line up and so forth. So if we open up to pi over 3, where's that terminal ray? Which quadrant? Which quadrant? First. Okay, so it's right about there, but when we go to a radius of -8, we're going to go way out here somewhere. Yes? So we're a third quadrant point. Can we all agree that -4 root 3 is a third quadrant point? So again, it's not going to be as obvious that it's exactly a match, but I think we can be pretty convinced if we kind of think about this point. -4 means that's -4. -4 root 3 means that's -4 root 3. And then how long was the hypotenuse? Based on that. I'll label it -8. And then you would be able to confirm that the Pythagorean theorem works there. 4 squared is what? 16 plus, what's 4 root 3 squared? 48, good. Equals, what's 8 squared? Okie doke. I would say that's the easier way, because the x and y, to get the x coordinate and the y coordinates, you have r and you have theta. So that's a pretty easy way. This way is a little bit more challenging, but not by much. So here's a rectangular coordinate. So we've got x and we've got y. So if you know x and you know y, you still don't know r or theta in either one, right? If you plug in your x here, you still have 2 unknowns, your r and theta. If you plug in your y of root 3, you still have 2 unknowns. So when you're starting with a rectangular coordinate, the first thing you want to do is start here and find your theta. And then once you know your theta, you can go back here and find you'll have your x and y, you'll have your theta, and then you'll be able to find your r. Yep, or you could find this one. So why don't we, or you could start with this one and find r first, and then go backwards and find your theta here. Let's do the first one using the tangent theta first, and the second one doing that first, just to see what little kinks might come up, little thoughts that you might have to think of. So for this first one, I'll say the tangent of theta equals y over x, that's root 3 over negative 1. So in which quadrants is tangent negative? So we're going to have to think of our quadrant stuff again. Okay, 2 and 3, no, 2 and 4, 2 and 4, so it's, this is out and that's out. Now, can anyone tell me which quadrant they know it is and why? Liam, what do you think? And why? Right, so he's going back, because these points need to coincide with each other, he's going back to the original rectangular one. Negative 1, root 3 is definitely in the second quadrant. So when it comes time to choosing which theta we're going to go with, the second quadrant or the fourth quadrant, we got to go back and use our basic knowledge of where that point is located to decide that. So we're going to omit the fourth quadrant just simply based on that. So what is the theta? Let's start with a reference angle. What is the reference angle that has a tangent of radical 3? Pi over 3. And since we're a second quadrant version of pi over 3, this is 3 pi over 3. So this would have to be 2 pi over 3. So theta is definitely 2 pi over 3. Okay, and now that we know that, we can go back and find our r value. And we only need to use one of these two equations to do it. So let's go with x. So negative, well, I'll write this down. X equals r cosine theta. So that's negative 1 equals r times the cosine of, now that we know theta is 2 pi over 3. So what is the cosine of 2 pi over 3? Okay, it's in the second quadrant, so cosine is negative there. And it's the reference angle of pi over 3. The cosine of pi over 3 is a half, so negative 1/2. So when you divide both sides by negative 1/2, your r value is 2. So the r theta equivalent is 2, 2 pi over 3. What's wrong there? Oh, nothing. Because 2 pi over 3 would open you up into the second quadrant, right? And the radius of 2 would bring you out to the 2. So here's something that we have to just all accept so that we're all on the same page. Whenever you're given a problem of converting rectangular into polar, because there are an infinite number of polar points that could be in that location, let's say that our theta, all of our thetas have to be between 0 and 2 pi. And we all have to use the positive r when we are converting openly. Because otherwise, on an open response, I could have 65 different answers if people wanted to be cute and give me, you know, a coterminal to this with the positive 2 radius. Or they could give me the fourth quadrant, what would that be, 5 pi over 3? And give me a negative r. So just so we all have to have the same answer, make sure your theta is between 0 and 2 pi, and make sure you're giving me the positive r value. Does that make sense? Okay? All right, so on the second one, let's do that the way Josh recognize as another possibility, which is find your R first rather than your theta first. So using that would be x squared plus y squared equals r squared. That's going to be 4 equals r squared. And then the square root of both sides is going to give me r equals, technically plus or minus 2, but based on what I just told you, we're going to all use positive 2. Okay, so now that you know r, again, we can do x equals r cosine theta. Your x coordinate you know is negative 2. Your r is 2 times the cosine of theta. So when you divide both sides by 2, you get negative 1 equals cosine theta. And then where is cosine negative 1? Pi. That's my phone. I'm sorry. Galen? Oops. Stephen? Let me catch everyone up to speed. So he's saying he used this one to find theta, and he used this one to find r. But we're not doing 2 pi. Does that cover your question too, Jalen? Okay. So yeah, I guess, you could definitely do it that way. Use this one to find theta, this one to find r, and be done with it. That's fine. Correct. Right, because we're making sure we're just going 0 to 2 pi, not inclusive of 2 pi. Okay? How do you feel about it? Let me just look at this one quickly. Negative 2, 0 in the rectangular system is right here, right? 1, 2. That's negative 2, 0. And think about where 2 pi is. You open up to pi, which is this terminal, right? And then 2 would put you there. A radius of 2. Make sense? All right. So your homework is 1 through 47. Oh, you want to start it? I will put while you're starting it, I'll put the sheet online. Jalen? Okay, so they wanted still the positive R value. So wherever my terminal ray ends, it has to end in that quadrant, because I want to use a positive R. So they also dictated that the theta has to be essentially negative. So I have to open up in the negative direction. So I'm opening up backwards, but I still want this to end in the first quadrant. So going backwards, knowing that my reference angle is pi over 3, this is negative 3 pi over 3. This is negative 4 pi over 3. And that in the first quadrant would be negative 5 pi over 3, just prior to getting to negative 6 pi over 3, which would be that full circle. Okay? All right, so I'll let you start. You're only going to be able to get through 1 through 9 without matching. But once you're done with 1 through 9, 11 through 19 is going to be the graphing. You can hold off on that, but you should be able to go over to 21 and start converting some of those, just so you're not wasting time. Is that okay? Can you read all that? Focus up. 6:55.